Or where are we? Even when we just punch out a number or call a function in GHCI and press return, it will evaluate as much as it needs and then call show on it. And then it will print that string to the terminal using, put the string on the line implicitly. That's why GHCI work, and we haven't done any compilation. Right, we just did checked through the let bindings, yeah. We did a refresher. Encourage you to do the same. They have to be in the form of let bindings in expression. Yeah, exactly. An important spot. Where bindings are names to be given to expressions, and expressions is the expression that is to be evaluated that sees them. We also said that in list comprehensions, the in part isn't needed. Well, you can use them in do blocks pretty much like you could use them in list comprehensions. Check this out. Yeah, so in do blocks, the in thing is not needed. Right, import data.char. In our do thing, we put a list, and then we get the first name, we get the last name, and then we let the big first name and the big last name. Oh, this is one big let thing, right? Yeah, let this binding, yeah, bindings, plural. This is another binding. We just let them be in here. Nice. Carbonated water for the win says, what I mean is two external functions, some random equations, become an external force of an expression that comes down to philosophy, more to philosophy than anything else. Right, but expression here, it's something very specific within Haskell, right? So we don't have to do any philosophy about what a function or an expression is within Haskell. They are clearly defined, so it's not really up for interpretation. These words are clearly defined, and me as a user as Haskell has to use the definitions that are used within GHCI, right? Well, within my compiler, right? I have to adapt to what my compiler says, not what my personal definition of these words are. If that makes sense, carbonated water. Right? Just like in Haskell, the word function means something very different from the word function within Python, right? It's the same word, but they mean something completely different. All right. This Stack Overflow stuff. Been thinking about that. I should do more Stack Overflow. Right, I read that there are no statements, just expressions in Haskell. I think an expression is something that reduces to a value, right? 1 plus 1 is an expression, right? It reduces to 2. But how about a number alone? 8? Is that 8 alone? Yeah. Is that considered an expression? Yes, it should be, right? An expression that doesn't reduce any further would be greater for the clarifications. Yes, 1 plus 1 is an expression. Yes, 8 is an expression. Whether 8 reduces further is a slightly complicated question. Just because of a strange detail in Haskell, numbers are polymorphic. Yeah, I was thinking about that. It can be... That's an integral, right? 8 is an integral. It can be an int or an integer. So, yeah, because of the polymorphic stuff. But an expression is just something that has a value. Carbonated water for the win says, but what is an expression but the forces pushed upon the individual, warped into understanding. Right. Since we're taking a philosophical stance on this, let's say X... Wait, actually. I wonder if we have wiki expression. How does Wikipedia define expression? Since we're doing philosophy, I'm assuming we're doing the linguistics bit. They call that a phrase. Is that what we're talking about, carbonated water? In syntax and grammar, a phrase is a group of words which act together as a grammatical unit. For instance, the English expression, the very happy squirrel, is a noun phrase which contains the adjective phrase, very happy. Carbonated water says, just because Haskell says it makes it so. Yes, within the framework of Haskell, when you're doing Haskell programming, if Haskell says that this is an expression, then yes, that is an expression. Like just, we've had that discussion before, I know. Like in, actually, let me give some space here. I'll give you an example of this, right? If we're doing base 10 mathematics, then this is by definition true. And that's because the math rules says so. However, if we're not doing mathematics and instead we're talking about romantic relationships and building those, we can say that one mom and one dad makes a child, and then we can say that they are 3, right? So it all depends on what context we are in, right? So an expression is the way Haskell defines it because we are doing Haskell stuff. If we're not doing Haskell stuff, an expression can be something else. For example, in linguistics, an expression is a phrase. Because if we're doing linguistics, like syntax and grammar, then our expression is something else, right? Carbonated water continue. No, your thought process in itself makes it truth in your psyche. Right, yes, exactly. Good point. That it's only true that it is an expression within Haskell because of my decision, if you will, my thought process of complying to the Haskell definition, right? That's up to me to comply with Haskell's definition. Just like it's up to me to decide that the word blue means the, well, I was going to say the color of the sky, but it's not blue, all right? That this here, right here, under my finger, that is a black color. That the word in itself, black, these letters, if we write them out, that's arbitrary. This whole thing is arbitrary. However, we can choose, or we can comply with the way of what things are, right? And that's the pragmatist approach to language. If I say black, you know what I mean because you have heard, right? You have this arbitrary couple of sounds put together. You've heard them so many times, so you have created your own meaning inside you what that means, right? And sure, we're all locked into our own subjective interpretation of the reality we find ourselves in. You can never access my thoughts just as I can, well, you can't access my experience just like I can't access your experience. Where did that go? Not here. Take the second answer. This was the first answer. This was the second answer. Give some examples of non-expressions in Haskell. Carbonated water says math can be falsified from external sources. Just like any intel, 2 plus 2 is equal to 5 for the modern Marxist agenda pushed to the youth. Your truth is what matters. Wait, I'm not quite sure I understand what you mean about this carbonated water. Modern Marxist agenda pushed onto the youth? I mean, for you as a person, right? For you specifically, your truth is what matters to you. I get that. But I would say there is a big value in trying to build systems and models of truth that we can agree upon, right? I'm kind of a pragmatist in that way, right? If I say 1 plus 1, I want you to think 2. Because I like to have maths be the maths system, right? We'll get Genotypes as 1 in one element field, 2 plus 2 is 5. Yeah, exactly, right? But in the general consensus, when you're out in the world and just talking to a random person, I don't want to be questioning if, wait, what is this? If someone says 1 plus 1, I don't want to be questioning if, what do you mean? I'm completely fine with having like, the norm being that 1 plus 1 is 2. And if you, however, want to talk and say that 1 plus 1 is 3, I feel like when you split away from the norm like that, I think it's up, you have a responsibility to define, yeah, exactly, in what field you are talking about, right? Right, you have to be clear and say, I'm not talking about mathematics now, which is fine, right? Communication is about you and me talking together, and you and me have a different understanding of what something means, or a collection of words means. Then it's up to both of us, right, to build an understanding where we can be in agreement. That's the whole point of communication, right? Building agreement and understanding. That's why it's such a good idea to have, what's it called? Yeah, regular structures that we follow. Definitions of words that are agreed upon. And then we build on that. Right, carbonated water for the winces. What I mean is truth in general is what matters to you. Okay? But that truth in itself is warped by the external sources that are taught to the populace. When you try to delve deeper into the concept, you dive into a massive saline pool of malarkey. Truth is what matters to you. I don't know what that really means. I think truth is a very, very interesting concept, but I don't know how much it cares. Like, I usually take a pragmatic approach personally, but that doesn't mean, right? That's my personal way of looking at truth. Just looking at truth here, we can say we have major theories. We have these major theories. We have these minimalist theories. Like we have, I mean, look at this. Truth is a very difficult concept to come to an agreement about, right? And what I like is, I don't even know if I like the pragmatic theory of truth. I'm not sure if I like that, but I take my personal pragmatic approach is that if I say something is true and you say something is true, then, well, in this context, it is true. Just like, what is an expression in Haskell? This dude says 1 plus 1 is an expression in Haskell. I say that's true. You say that's true. The compiler says that this is true. So within our context, this is true. 8 is an expression for the same reasons, right? Truth in itself is a very fluctuating concept, eh? Yeah, exactly. That's what I started out saying. In this context, within Haskell, this is an expression. Right? That's how we started out this whole discussion, right? Saying that it's a fluid, but within this context, and that's something that is quite nice with programming, eh? That there is not a lot of room for interpretation at the level of skill where I am, right? Just like when you're learning maths as a beginner, there's not a lot of room for interpretation. If you see 1 + 1, then you're gonna have to say 2. Let's see here. To elaborate on Amaloy's comments about there being more than one expression in Haskell, more than expressions in Haskell, you normally make the distinction between statements and expressions in imperative languages because you have something like x is equal to 2 + 2 with the thought being a statement and the 2 + 2 being the expression. Alright, this is the statement and the 2 + 2 is the actual expression. The body of a Haskell function is always one single expression, although with where you can split that expression apart for convenience. And this is the main distinction that drives the questions. So if you want to do more than one thing, which is an imperative notion of a function being able to change a global state, you solve this with monads. Shit, we can't read about monads yet. We haven't gotten to that. This is spoilers, Colgating on tab. We can't read this yet, the second answer. But I get that. Alright, so is this saying that a function is also an expression? Right, an expression can be a collection of expressions. Is that what we're saying? That brings me back to... we went on a sidetrack here. But it brings us back to our let bindings in expressions. And there is said that we could split up our expressions with where bindings. In the same way, we can split up our expressions with let binding. Colgatino tab says, for example, import data.list is not an expression. Oh, right. This is not an expression. Yeah, exactly. Just like do is not an expression. This is not an expression. It? Type signatures are not expressions. Yeah, expressions is a value, right? That's what an expression is. It has a value. Right. This is an expression. For example. Alright, they have the form of let bindings in expressions, where bindings are names given to expressions. Yeah, bindings are the names. So this is not an expression. This is just a name of an expression. And the expression is the expression to be evaluated that sees them. We also said that in list comprehensions, in isn't needed because just like in list comprehensions and do blocks, we can just define them. See how the IO actions in the do block are lined up? Also notice how the let is lined up with the IO actions, and the names of the let are lined up with each other. Just pointing out its syntax, right? Yeah. That's good practice because the indentation is important in Haskell. We have started to notice that, yeah. Now we did map to upper first name, which turns something like John into a much cooler string like John. Why are we shouting? I don't know if that's cooler. I think cooler is more chill, right? I think that's a hotter one because we're screaming. We bound that uppercase string to a name and then used it as a string later on that we printed to the terminal. We did that indeed. Carbonated water wonders, what is the concept of split expression for Haskell? It's such a vague concept that it goes back to Da Vinci, Plato, Epicurus, and Herculetus. I haven't... Well, I've read Plato, I suppose, and I've read Epicurus, but... Epicurious? Is that how it's spelled? I don't remember. I just remember the name. I don't remember what Epicurus said about anything. Maybe I'm messing stuff up. Maybe I don't remember that at all. I do remember the Plato name, though. So a split expression, my understanding is that you just use a where binding to make it more readable. Yeah, make it more readable. It's just a way of splitting an expression up to multiple lines. It's just a syntax function to that. You may be wondering when to use the binding and when to use let bindings. Let's think about that for a second. Do I understand that? Right, we bind some IO and we bind some other IO, but this is not a bind thing. This is... No, this is a bind thing as well. Yeah, no, I don't know. Why do we use one or the other? Good question. Colgatino says, with where binding, you can have sub-expressions for your expression. Yeah, exactly. But you can also look at it all as one big expression, right? You could have written, you don't have to have the sub-expressions. You could have written it all with one big fucking expression, and that would be awful and not readable at all. That's why you do the sub-expressions, right? Colgatino. Right, well, remember, the binding thing is for now for performing IO actions. Right, that's it. We bind as an action. And binding their results to names. Yeah, exactly. We're performing an action. That's when we use this thing. So use the binding arrow when you want to bind results of IO actions to names, and you can use let bindings to bind pure expressions to names. Exactly, there we go. Actions and expressions, exactly. When we do IO stuff, this is not an expression, that is an action. It's an action. Colgatino says, no, you do them to flex with your where skills. Nice. Weird flex. Carbonated water for the wind says, from what I understand, those ancient thoughts pushed duality as a concept. Granted, you enjoy a partition of it, but you dislike the secondary. How do you mean? I mean, duality had been a thing. Duality was a thing for a long time. It still is, right? And I mean, there is part of... That's because we find ourselves in a kind of... It's easy to divide the world into a dual kind of set of things, right? There is my experience of things, and then there are the things. So thinking in duality is... It's not very surprising at all, right? In any philosophy. Thinking in duality, yeah. Because that is how we as humans, or I assume all living beings, especially on this planet, maybe not all of them, right? You have a collection of cells that are bound in within a body, and this body interacts with everything else, right? From the inside to the outside and whatnot. Carbonated water says, where would contradict now and why thoughts? You have to be more clear than that, carbonated water. I don't understand that question. What are now and why thoughts, and why would where contradict them? Tab says, if you don't mind them showing outside functions, you are working with... Wait. You don't mind them showing outside functions you're working with, you could define them as their own functions outside of your bigger expression. Yeah. But good practice, Tap, is that when you define a function on its lonesome, that is when you need to call it more than once. If you only call it once, then it's better to have it within your function, right? Within your expression. Yeah. Have the generalized functions to be their own functions if you use them more than once. Oh man, I'm not doing that though. With doing these, what are they called? Yeah, these tests. Look at this. Actually, I guess this flip thing is... That is something that we could use somewhere else. There we go. Where we flip a binary string. It's a string of binary digits. Characters, ones and zeros. Carbonated water for the win says, from what I understand, it is how most understand the world around them, adherence and contradictions. Oh, that's how you build a worldview, how you understand the world. Right? If the world adheres to your idea of what is going to happen, then everything is hunky-dory, right? Everything is fine. But if something happens that contradicts your worldview and your understanding, what you think is going to happen, then you change your mind. Or that's not really how it works in psychology, but that is kind of how it works. Oftentimes you can go, if there's a contradiction, you can also reject your observation of reality, right? You have different ways to go, right? If you're entrenched in an idea, or if your idea of how the world works is bound up with ego or whatnot, it's very easy for that. If you found a contradiction, that something happens that wasn't supposed to happen, then it's something wrong with the world, not your understanding of it. Is there another way to to understand the world, carbonated water? Is there another system? It's also a dualistic system, isn't it? Kinda. Volgatinotep says, well, if you put them all into the same where, they can each see each other, so it's fine. You need them in multiple places. Oh, you could do that, sure. Right, where were we? IO actions. Yeah, we have to do the... wait. Your expressions to names. Had we done something like let first name equals to get line, that doesn't work. We would have just called get line IO action a different name. Yeah, exactly, a different name. Oh, alright, so first name would be get line. So when we called first name, that would be an action. An IO action, exactly. This is pointless. Renaming a function, or giving a function giving an action another name. There we go. Carbonated water for the win says, who says it isn't the other way around though? What is? It is possible the world is wrong from your understanding at face value until you experience it, such as Jung's thought process. I mean, again, right? There is our experience of the world, and then there is the world of itself. Personally, I take a very Immanuel Kantian view on this whole thing, right? There is the thing in itself, and there is my experience of the thing in itself. My experience doesn't necessarily say anything about the thing in itself, right? I have to recognize a pattern, and that said pattern, when I recognize it, I adapt to that pattern, right? It's all statements about me, right? That's what you said, right? From what I understand, it's how most people understand the world around them. This was not a statement about what the world looks like. This was a statement about how people understand the world. So the statement was about people, or beings, if you will. Beings in the world. It was not a statement about the world itself. And I think it's a mistake to conflate the two. That makes sense? Collegatinotap asks, was it a statement or a declaration? Yes. No? Maybe. Carbonated water for the winds is true, but it leads to your understanding of the concept. Yeah, which can be collected into a whole with enough registered data. Yeah, exactly. It leads to my understanding, just like your stuff leads to your understanding. I mean, the only thing you have are your observations and your memories, right? That's the only thing you can use to build an understanding of the world. Right? Carbonated water for the win. If you don't, carbonated water for the win says exactly. Yeah, so then you end up with that type of understanding, right? Adherence and contradictions. Contradictions, yeah, like we said before. So what did you mean the other way around? It is possible the world is wrong from your understanding at face value. Till you experience it. Right, but even if you experience it, if you have, like... And I'm pretty sure Jung would agree with this, right? Because Jung... How do you pronounce his name? Jung? I don't even know his first name. But his whole deal was integrating the shadow, right? That was a big thing he had in mind. And that was that you, like, pretty much stop rejecting observations. Do the observations and don't reject them. Instead, internalize them. So from Jung's point of view, right? It would be when you reach a contradiction, you could say that Jung's whole strategy was that don't reject your observation within a contradiction. Instead, look inwards and try to improve of what exists within. That's usually ego trying to protect ourselves. That's usually the Jungian thing to do, right? When your ego comes up and starts being problematic, it's trying to protect you. No, it's trying to protect your worldview, your understanding of the world. But instead, you do practice to put the ego aside and improve your understanding of the world, I suppose. Carbonated water for the win says concepts in general are just that, concepts. When you push it on others, they are just a process of the overall thought itself. Push a concept on others. That's just... I don't quite understand what you mean. Right, pushing concepts onto others. That sounds like something a teacher would do, right? Like the author of this book that we're reading right now. He's pushing concepts of let bindings and expressions and functions and like... That's pushing concepts out into the void, rather. And me, right? Push it on others. It takes two though, right? Communication. Even if you have one-way communication, it's always... You have a speaker and a listener, don't you? Right. Now we're going to make a program that continuously reads a line and prints out the same line with the words reversed. Right, I just did that, didn't we? The program's execution will stop if we input a blank line. Program. Take a look at that in a second. Carbonated water for the win says, isn't that the overall thought process? We push our own thoughts, our own thought beliefs onto others to sway them into our train of thought. I mean, now you're talking about Nietzsche's idea of will to power, right? I wouldn't agree that it's the overall thought process. I would definitely agree that that is behaviors that we engage with. Right? Definitely we want to, our understanding of the world, we want to, and how we want the world to look, right? There's a secondary step there, right? Now we're talking about opinions. And opinions are like assholes, right? Everybody has them. I have them. You have them. Everybody has opinions. And these opinions we want to make into reality. But that's not the overall thought process, right? I'm not... Take example. When I read this book, sure, I'm reading it out loud and I'm pushing it to the outside world for people to learn Haskell with me, but if we just took the camera away and I'm still reading the book, I'm not reading the book to push my ideas necessarily, or my improved ideas on the rest of the world. It's not... They are not necessarily married, right? They're not intertwined necessarily, right? You can learn stuff about the world and not try to push that onto others. But we definitely do, right? We definitely do. Not everything though, right? For example, I have the opinion that metal music is the best music. I'm not even sure if I agree with that statement, but I have that. I really like death metal, for example. But I don't want to push death metal onto other people. That doesn't make any sense to me. To have other people liking death metal. I know a lot of people who don't. Like they don't like the screaming, the growling or whatever. And that's fine. I have no desire to push that onto others, if that makes sense. Colgate on Tap says, it took me quite long to figure out the solution to the puzzle that had Jung as a solution. Never heard of this. There was a picture of Jung named psychiatrist.jpg. The title was Who is this guy? Source code has as comments nonsenists pas Henri Lejeune, and nah, he's not Thomas Jung either. Isn't that what's it called? There is no pipe. Business pass. Yeah, it's a reference to this, right? Colgate on Tap. That puzzle. Treachery of images. I'm assuming that's the one because it's kind of relevant in the discussion as well, isn't it? Carbonated water for the win says, isn't it though? Aren't you giving your opinions to others through streaming? Yeah, definitely. Through streaming, I'm pushing my opinions on others. But it's not only that. I'm trying to learn from others' opinions as well and improve my own. Right? And sometimes I just like to express myself. Just expressing myself isn't necessarily pushing any ideas your way, right? So it's not only that. It's partly that. To push your overall understanding of the world. Yeah, it's partly that, but not completely. That makes sense, carbonated water? It's about learning and improving and expressing myself. You could probably, with a certain type of lens of viewing things, that you could say that expressing yourself is pushing your ideas. But that's not the goal. The goal is not to push the ideas. It's more of an internal goal, if that makes sense. It's more about me than you. Right? So it's a multifaceted. I haven't really analyzed it, but just shortly we came up with 3 different things. Colgate on Tap says nest pass just means no, it's not. Yeah, it is not. But, however, Colgate on Tap, since the puzzle Colgate on Tap that you run into, did it in French? And if you search for, just search for this in French. If we just search in start page, we just search for it. What will end up? Alright, Duolingo. Actually, it didn't show up. I was sure that the image would show up immediately. Right? Yeah, I'm actually surprised. Because that image is so famous, right? It's pretty much the only French I know. Baguette? Oh shit, that was racist. No, that's not racist. It's culturally insensitive. Yeah. Not racist. It's culturally insensitive. Making fun of another culture like that. Like if I started waving a white flag around. Culturally insensitive. Carbonated water for the win says, I can respect that. True understanding of the universe is key to our understanding, in my opinion. Oh, yeah. I don't think true understanding of the universe is something that is achievable, but I think that having a goal to build and improve your understanding of the universe throughout life as an explicit goal is a very worthwhile goal. So I think we are in agreement in our opinions there, Carbonated Water, even though our metaphysical understanding of the world may differ, our opinions are very similar. Colgate Tap says June is young in French, young is young in English, young is young in German. If I was more familiar with psychiatrists, it would have been easy. Yeah. Yeah. I mean, it was kind of easy now, I guess. It's an abomination of the Latin. No, it's not. Nice. Abomination. Is that's again culturally insensitive, isn't it? Like, oh, wait, what do we do with all the French words in English? Are those abominations as well? That's quite interesting. When talking about natural languages, I think English is one of the most bloated languages there are, because you have French words for everything, right? Yeah. Well, not everything, but a lot of things. If you want to sound more posh, you say it with the Frenchified English word. I don't know. Colgate Tab says, well, I had to find Jung from Wikipedia's list of psychiatrists first. Oh, psychiatrist. Oh, yeah. Jung, he's interesting, but wait, the solution to the puzzle, Colgate Tap, is that it's just an image. Right? It's just an image of the psychiatrist Jung. This is not Jung. Right. What were we doing? We're reversing stuff. Main, do. We get a line. We're not even warning. That's just get line is, it's asking for an input, right? So someone has to do write and press enter. That's input. If null line, right. If we have an empty line, then we return nothing. Else do, right, print a string and then return to main. So we just keep going on and on and on and on forever until we return an empty list. Empty line, sorry. I'm assuming null line is just a backslash n? No, the enter sign. And then we have our function down here, reverse words, string a string, unwords. Oh, right. We turn it into words, we map reverse on each word, and then we unwords it. Because we just want to print a string, right? This takes a string, so it has to take a string. This looks very much like all the imperative languages. That's what the do functions are. Because we can't be pure functional, we have to be dirty. I don't remember. What are you? A dirty whore? Is that what we are? We have to be dirty whores? That doesn't feel good in my mouth. That's what she said. Oh. Carbonated Water for the win says that we are. English is a very bastardized language, right? Britain was invaded and invaded and invaded. And then they had enough. Now we live in a British Empire. Oof. The British was pissed off. Well, Conditional tab says username read, password alert. What is this? This was the puzzle. We have to be dirty, you slut, right? Yeah. Absolutely Ash. Nice to see you. Absolutely Ash. How are you doing today? Makes me think of the experiments. Oh, you probably heard that a lot of times, right? With your name, Absolutely Ash. The conformity experiments. Well, nice to meet you. It's still functional, just hidden behind the do notation. Yeah. Well, functional, but the actions, right? But didn't they use that? They called them dirty. No, they said tainted. Those were the words of the text. Yeah, this stuff is tainted. This stuff is not, right? Functionally tainted. Right. To get a feel for what it does, you can run it before we go over the code. Oh, do we have to? I mean, it just reverses the words, right? It would say, like, if we put this as a string, it would give us SDRO. Well, actually, if we gave us this as a string, we would get PAMESREV. I mean, you see what's going on, right? We reverse the words, not the order of the words. Carbonated water for the win, tainted. Ooh, the atrocities, right? Yeah. Oh, right, we're not doing any I.O. Well, the get line is I.O. though. Absolutely Ash. There's nothing dirty about do notation. The only thing dirty is the I.O. Here is the filth. The filth is right here. The get line. This taints our program. It's the outside world that is dirty. And I guess put string is tainted as well, isn't it? The whole point of do notation, absolutely Ash, isn't the whole point of do notation is to do filthy things, interact with the world outside? Or is there other reasons for I.O.? Yeah, Colgatino tab says this is also I.O., yeah. Right? We take some filth in, and then we do some proper squeaky clean function stuff, and then we retaint it. Since that's the only reason I've seen do so far, I thought that the whole point of do was to do this specifically. Oh, again, with the monads again. No, the only point of do notation is to write monads in a better way. Do notation has nothing to do with I.O., only that I.O. is a monad. We haven't gotten to monads yet, yeah. Colgatino tab says Spinoza was right all along. Spinoza would love Haskell, wouldn't he? I mean, I don't even quite remember. We did read Spinoza. That was a long time ago, but Spinoza felt like a dumbass to me. In philosophy speaking, right? But yeah. I'm feeling a little bit looking forward to the monads, maybe. Right, to get a feel of what it does. Alright, we got that. Pro tip. You can run a program. To run a program, you can either compile it and then run the produced executable file by doing... Right, we create the file and then we run it, or wait, you can use the run Haskell command like so. Run Haskell hello world. Oh, nice. And your program will be executed on the fly. You know what? There is another way to do it that I've been doing. I think I'm actually happy with the way I've been doing it. Right, what we've been doing. Oh shit, broke this, didn't I? Right, but just doing main. Shit. Where's my blue thing? Did I forgot to save this? There we go. There we go. And then just calling main. Because in here, right, I can probably do type convert, right? Yep. So I like running them within GHCI. So there are... I didn't know about run Haskell. Run Haskell is good for just testing output and getting errors, I guess. But you can also sit in GHCI and just load it. Maybe it's better to just run it, because in GHCI we might get error messages that confuses us. Maybe run Haskell is the better choice. Carbonated water for the wins is... Alright, you glorious bearded bastard. Time for me to go to bed. Have a good one, eh? Oh, that's very kind of you. Thank you. It was nice of you to stop by as well. Yeah, sleep well and yeah, have a good one. Absolutely Ash says, I always felt it was a bad start with I/O in Haskell books or tutorials, since I/O is a very special, dirty monad. Oh, wow. We've been talking about... This is chapter 9 in Learn You a Haskell, right? And I was thinking this is way too late. I actually like this. And I still think that we should have learned I/O, the filthy, dirty monads, sooner. Because this lets us compile stuff, right? It lets us compile stuff. I don't know. It lets us actually do stuff, right? This lets me, even though I had to go around the actual book, what we started doing was here. Yeah, we started using this. We started using I/O, right? Importing stuff from the outside world. So I think, yeah, to be more functional, not in the Haskell sense, but functional like in the pragmatic kind of sense, that you can use it. I think this would have been way earlier. And I also think this is a good, since I don't know monads, I'm thinking that maybe this is an introduction to monads. And it's one of the most important things to be able to do with a programming language, right? Get some input, produce some output. It's super important. Colgatinotap says Gottfried Leibniz was a pretty smart nerd, and he also advocated for monads. Did he? I don't remember Leibniz. I don't think I've read Leibniz. He was more of a mathematician, wasn't he? Rather than a... Well, back then they were all of those things, right? Mathematicians, philosophers, physicists, whatever. Absolutely Ash says, I always debug my Haskell in GHCI and just do :R to reload the file. Yeah, way faster than compiling and rerunning kappa. Yeah, exactly. That's... Isn't that... Oh, I love to hear that, because that... I really like the :R as well. And I suppose you get used to the possible confusing error messages that might show up. You will get used to them, yeah. Yeah, that's what I thought. Leibniz invented calculus or something? Yeah, what I thought. Absolutely Ash says monads are just monoids in the category of endofunctors. Nothing not mathematical about that, Kappa. Oh shit. Maths. Is it time to run away? I don't know. Right. First, let's take a look at the reverse words function. Just a normal function that takes a string like hey there man and then calls words to produce a list of hey, there, man. And then we map a reverse on the list. Yeah, Erit, Nam. And then we put that back into one string with the unwords, and the final result is... There we go. See how we use the function composition here? Yes. Right. Actually, I have a question. You guys know Haskell, right? So I have a question. Why do we do function composition? Wouldn't this just work with the $sign as well? $sign, $sign. And why is it better to do it as a function composition? It would probably work, yeah. So why do we do compositions? It would work in this case. Yeah, in this case. Are compositions preferable when you can do compositions? Oh, actually, I assume that the optimizer just optimizes it all away anyway. Is that how it works? That it doesn't matter, I'll just do whatever makes me happy? But learning compositions might be a good idea. Right. See how we used function composition here. Without function composition, we'd have to write something like reverse words, unwords. Yeah, exactly. All the parentheses. That almost looks like Lisp. Oh, gross. Never mind, it didn't work. Damn it, it didn't work. Why not? Let's... Hello, world. Wait. What did I do? Couldn't match expected type. I always do this. Why doesn't that work? Possible cause. Words is applied to too many arguments. Namely words and then a string. Hello world. Second argument. Oh man. Do I have to like do it like this? Reverse. Weird. And then reverse. Oh, it worked. That's weird. Oh, right. That whole thing. So, but I could do this, right? Oh, shit. Yeah, that would have worked. But that also makes... That's probably why this doesn't work. This won't work because... Yeah. No? It worked just fine. Man. That won't work though. Yeah. Interesting. Okay. Yeah, but that was a sidetrack. Again, a lot of sidetracks today. Some philosophy, some this and that. Well, Conditional tab says import data.bits. Oh shit, was that what we needed yesterday? Call Conditional tab. Count to integer pop count. No, wait. Import data.bits? I don't know what that is. All right, count is to integer count. I mean, I have no idea what those functions do, so... Yeah, it's an example of when the composition works, but the dollar sign does not. Yeah, but since I don't understand the functions, so I don't understand why the functions would or would not work. Right, what about main? Let's keep moving. First, we get a line from the terminal by performing getLine. And we call that line. Now we have a conditional expression. Remember that in Haskell, every if must have a corresponding else, because every expression have to have some sort of value. We make the if so that when a condition is true, in our case, when the line is entered blank, we perform the IO action, and when it isn't, the IO action is under the else is performed. That's why an IO do block ifs have to have a form of if condition, then IO action, else IO action. Right, exactly. I remember that. Conditional tab says pop count gives amount of ones in a binary composition. Pop count? Why is it called pop? A weird name, isn't it? Like pop count 28 would give 3 because 28 is 11100 in binary. There we go. Interesting. Right. Let's first take a look. Wait, let's first take a look at what happens under the else clause, because we have to have exactly one IO action after the else. We use a do block to glue together two IO actions into one. Could also write that part as else do. Oh, I missed that part. Ooh. That confuses me. Wasn't the whole point of a do thing that... Right? The do thing is that we're able to do multiple things. Multiple actions, right? We don't say then do return, but we say else do. Why not then else? Welcome to do notation. Thank you, that's super confusing. Why don't we say then do, else do? Do is one expression, else takes one expression. Turn is also just one expression. Right, so then... Oh! Then takes one expression, else takes one expression, and since we're doing more than one thing, we use the do expression to... Do is an expression that does an array of actions. Do a couple of actions. We could do an unspecified amount of actions as one expression. You got it? Nice. Thanks, absolutely, Ash. That's why we need to do, because we put the string and we call main again. That's one action, and this is another action. Therefore, we need the do statement. Okay. Now, just to remember that. I'm assuming we get a nice looking error message. Yeah. Not in the mood to copy paste and make that function just to take a look at that error message. Hopefully we'll remember when we get there. Where were we? Here. Right. Yeah, this makes it more explicit. Fine. Nice looking error message in Haskell, asks Colgate on tap. Yeah. I don't think I've seen one of those yet. Absolutely, Ash says I'll take Haskell error messages over C++ error messages any day. Oh man, I hear many horror stories about C++. I've never tried C++. The horror! The horror! And this makes it more explicit that the do block can be viewed as one IO action, exactly. But it's uglier, yeah. I think this author and me are kindred spirits in our distaste of Lisp. Anyway, inside the do block we call reverse words. On that line we got from... On the line we got from getLine, yeah. And then we print that out to the terminal. After that we just perform main. Exactly. Called recursively, and that's okay because main is itself an IO action. It is, yeah. So in a sense we got back to the start of the program. Yeah. It's a recursion, but it looks a lot like a while loop. Like a lot like a while loop. Colgate on tap says, I wonder if there's a Learn Haskell in the Lisp Way guide somewhere. There probably is. There are a lot of people, well... I think the people who are really into Lisp, right? Something tells me that they probably won't have too much difficulty learning a new language. Right? Because who are the people who like Lisp? It's the people who love to live in Emacs, right? That's it? That's the Lisp thing? Emacs? That book wouldn't have to introduce the $sign, right? Yeah, it wouldn't. Now, what happens when null line holds true? What's after the then is performed is this in this case? In that case. Right, we just return the empty tuple, right? It's over, we're done. Absolutely, Ash says recursion isn't used too much in real world Haskell. Oh wow. That's just, it's mostly just higher order functions. If we look up, we'll see that it says then return. Exactly. If you've done imperative languages like C, Java, or Python, you're probably thinking that you know what this return does, and chances are you've already skipped this really long paragraph. Oops! Oops! Yep, that's what I thought. Actually, I got the feeling that is how it got explained to me, right? We already read some stuff about this returning this thing, but... Well, here's the thing. The return in Haskell is really nothing like the return in most other languages. Ooh. It has the same name, which confuses a lot of people, but it's really quite different. Okay. Why the fuck did you name it return? That's... Whoever named it return should have a slap on the fingers. Yeah. Colgate on tab says, oh, poor souls who skipped that paragraph. Nice. In imperative languages, return usually ends the execution of a method or subroutine and makes it report some sort of value to whoever called it. Right. That's not quite what's happening. That's not really my understanding, right? Hmm. Absolutely, Ash says return is a terrible name. It should be called box or wrap. Ooh, I think I like wrap, even though I don't have no idea what's going on anyway, but I think I like wrap because it makes me think of those, you've seen those Hollywood clips and they do the thing and then they say, that's a wrap. Maybe that's taken as well. I like box, it's short to type. Good point. In Haskell, in IO action specifically, it makes an IO action out of a pure value. Right. If you think about the box analogy from before, it takes a value and wraps it up in a box. The resulting IO action doesn't actually do anything. It just has that value encapsulated as a result. So in an IO context, return, haha, will have a type of IO string. What's the point of just transforming a pure value into an IO action that doesn't do anything? Why taint our program with IO more than it has to be? Well, we needed some IO action to carry out these cases of an empty input line. That's why we just made a bogus IO action that doesn't really do anything by writing return and parentheses. Absolutely, Ash says that return is a function that all it does gives you the value, give it in the monad of the function you're in. Man, still don't know about monads. I'm assuming that this is a monad. This is a monad, assuming. So yes, you can just do return. Wait. Why would we want to return 3 empty tuples? IO is a monad. Right. Alright. Feels like spoilers. We're doing IO. Oh, shit. Clean this up a little bit and boom. Here we go. My face in the way? No, we're fine. Info for IO. Right. Type IO of. Shit, we read this. Takes a type and returns a type, right? Instance, right? It's not info, it's instance. Monad. Monad is just a type class. Oh. Monad is a type class. Oh. Okay. New type IOA. Types. This is. I have no idea what's going on here. Functor, monad, monoid, semigroup. This doesn't help me. Yeah, this doesn't help me. I don't understand enough of Haskell to understand what's going on here. I think we'll get to it. I think it's spoilers. Yeah. No one knows what's going on in IO? Okay, it's not just me then. Nice. Alright, so what's the point? Return haha is just an IO string. So return this is just an wait. This is just an what is the type of this then? Empty input line. That's why we made a bogus IO action that doesn't do anything. Oh, it doesn't do anything. Using return doesn't cause the IO do block to end in execution or anything like that. For instance, this program will quite happily carry out all the way to the last line. Oh, that's what you were saying, right? We can return. So it doesn't end execution, it just does nothing. Colgate in on tab says, real world is scary. Oh, yeah. Absolutely Ash says, I once worked on the GHC and I have no idea what's going on in IO. It's just real world to me. The type of return here is IO. Oh, because... Oh. All right. I'm super confused by the return thing. All right. All these returns do is that they make IO actions that don't really do anything except have an encapsulated result. That result is thrown away because it isn't bound to a name. We can use return in combination with bind to bind stuff to names. Return hell, return yeah. So where was the return thing? Right. Then takes an expression and return is just an empty non-action. That is what this is. This is a return in itself. It's an action. Right? Return is an action that returns something. And if we return nothing, the action is not doing anything. Maybe? Type of return, hahaha, is IO list of characters. Oh. IO is a 0 tuple. IO 0 tuple. But return in itself is just like put string, it's an action. They don't return from the do block, they just get. Right, they don't actually do anything, but we can bind them. So we return hell into A. So you see, return is sort of the opposite of bind. While return takes a value and wraps it up in a box. Oh, the bind takes a box and performs it. And takes out the value out of it, binding it to a name. But doing this is kind of redundant, especially since you can use let bindings in do blocks to bind to names, like so. So box is probably a good name if you think box like a verb. Box, yeah. Well, this is unbox. Is that what we're doing? So we box it in an... Right. Actually, I kind of like why we're doing it in IO stuff, right? Because thinking of tainted and not tainted stuff makes it easier, right? We box in this taint and we unbox the stuff. We put a condom on it. Kinda. Return makes a monad, takes out of a monad. Yeah, exactly. So a monad is a condom. And returns put the condom on, this thing takes the condom off. It makes a lot more sense in other monads, trust me, Kappa. Well, I'll take your word for it. We'll get to it when we get to it. So you see, return is sort of the opposite. Yeah, exactly. Doing this is redundant. Yeah, we just put something in a box and then we take it out of the box, which is weird. Right, so, and we could have just do the let A be hell and let B be yeah. When dealing with I/O do blocks, we mostly use return, either because we need to create an I/O action that doesn't do anything, or because we don't want the I/O action that's made up from a do block to have the result value of its last action. Right, yeah. But we want to have... we want it to have a different result value, so we use return to make an I/O action that always have our desired result contained, and we put it at the end. Right, because our do thing always have a result. So this would have the get line as the result, right? This whole thing would have that I/O thing as a result. No, wait, it's always the action. The action has a result, which is on here, which is this. And shit's confusing. Oof. A do block can also just have one I/O action. In that case, it's the same as just writing the I/O action. Some people would prefer writing then do return. In this case, because the else also has a do. Before we move on to files, let's take a look at some functions that are useful with dealing with I/O. I think we will look at those functions, maybe not tomorrow, maybe the day after tomorrow. Yeah, because it's lunchtime. It's lunchtime. Nice. So, alright. Yeah, we'll do some more Advent of Code tomorrow, probably. So, thanks for hanging out. And yeah, have a good one. Cheers.